with me, I won't grade it. Hit the submit button, I will grade it. So to get started, I'm going to go ahead and just full screen mine so it makes it a little bit easier. And what you're going to do is you're going to click on a lot of these models, and you're going to be using this edit feature here for the picture to edit the picture that I pasted in there. So for this first one, we are learning how to draw something called a Bohr model. The Bohr model is a very simplified version of an atom so that you understand what parts go where, and you can visualize the valence electrons and the parts of the nucleus and so on. So I'm going to be making it the structure of this atom here in these first four steps. So you're going to need 5 protons in the nucleus, 6 protons in the nucleus, 2 electrons in the first ring, and 3 electrons in the second ring. And then you're going to use your periodic table to figure that out, what element we're talking about here. So the nucleus is the center of the atom. That should be no surprise to anyone. So you're going to click edit. And you're going to have this set up. So first, you're going to click on the proton. You should see this box come up around it. So it said to put 5 in there. So including this proton that I gave you, you're going to make 4 additional copies for a total of 5. So to make a copy of something, you're going to hold down the control key and hit C. That makes a copy. You're not going to see anything happen right away. Then you're going to hit the control then V key in order to make a copy of it. It should look like that. And I'm going to make 4 additional ones like this. And I'm going to place these in the nucleus. So it says put them in the nucleus. 1. Click and drag them to this gray section. It doesn't have to be in any specific order as long as it's relatively organized in there. So it says to do it for the neutrons too. I'm going to hit Control C and then Control. It wanted 6, so I need 1, 2, 3, 4, 5, 6. And you click and drag these into the nucleus as well. And again, the order doesn't matter so much. All right. So now you have your 6 neutrons, your 5 protons, and then something that you should remember from our notes is that the number of protons in an atom is equal to the total number of electrons. So if you have 5 protons, you're also going to have 5 electrons. I'm going to hit Control C and then make 5. So I have 1 already, 2, 3, 4, 5 total. Now I'm going to put some text down here to kind of illustrate a point. So let me make sure my font's big enough for you to see. So you're going to have 2 rings here. In the first ring, you can have a total of 2 electrons. In the second ring, you can have a total of 8 electrons. So as you see here, you have more electrons than will fit in this first shell. So once you fill that shell, you're going to place the remaining electrons on the next ring. So I'm going to click and drag 1 electron, 2 electrons. That makes 2. Then I have these 3 that are left, and they're all going to go on the next ring. Since the next ring can hold up to 8 electrons, that will make things pretty easy for me because I only have 3. So I'm going to put 1, 2, 3. And this is what your atom should look like when you're done. And hit save and close. And you'll have this picture that's edited up there for me to grade nice and easy. Now, it says what element is represented here. Now, if you look at your periodic table, you want to notice a couple things here. Once mine loads, is that there are 2 rings and 3 valence electrons. So if I remember, the rows represent the rings, and then the columns or families represent the number of valence electrons, excluding the transition metals in the middle. So if I go across 2, since I only have 2 rings, and I have 3 valence electrons, I should wind up at boron, because 13, if I ignore the 1, makes 3. And then it intersects at the second row here. So that's boron. So boron is my answer. And you can also know that from the number of protons. Boron has 5 protons. The atomic number tells me how many protons there are, and that is the atomic number 5. So let's recap that. When you're looking at these in part B, label each section. So this is supposed to be, I apologize for the alignment being a little bit off here, but it's fine. You know what I'm talking, you get what I'm getting at. So with this in mind, this at the top is the atomic number. This is the symbol. Oxygen is the element name. And 16 is the protons in the element. I'm sorry, the protons plus the neutrons is the atomic mass. So this is the atomic mass. Oxygen is the name. O is the 1 or 2 letter symbol. Every element has 1 or 2 letter symbol. Not all of them make sense. So for example, iron does not have an I in the symbol, but instead Fe. And up here, that represents the atomic number. So you can fill those in. And then just like we talked about over there, I'm repeating this over here because 7 and 8 will help you answer the whole table on number 9. So what does the atomic number tell us? The atomic number tells us the number of protons. It's like the 8th time I've said this. And the number of total electrons. The atomic mass is this number down here. And that tells us the number of protons plus the neutrons. Because remember, the protons and neutrons create all the mass of the element. They are in the nucleus up here. They contain all the mass. The electrons are so small that they don't have any mass. So the key here is to keep these two in mind as we complete the table here. So the atomic number is equal to the number of protons. The atomic number will be equal to the number of protons. So I'm going to go ahead and I'm going to highlight this just to help you out. Atomic number equals the number of protons. And remember up here it says the protons tell you the total number of electrons in a neutral and a stable atom. So everything highlighted in blue right now should be the same number. Then the neutrons plus the protons will equal the atomic mass. So for lithium, if you have the atomic number of 3, that means the protons will be 3, and the electrons should also be 3. Now, the only thing we have missing here is the number of neutrons. So you have to ask yourself, what plus 3 equals 7? And that will be your answer. Go ahead and put all these in the center so they're nice and organized. All right. So the same thing will be true for down here. I give you enough information in every row to answer every blank that's in yellow. So next up, the atomic number of chlorine, remember, is equal to the number of protons. So that makes this one real easy. 17. 17. Again, you got to ask yourself, what plus 17 is 35? And if you subtract these two, it'll give you your answer. And you can go on and fill in the rest of the table using these rules. So remember, the atomic number is equal to the protons and the electrons. And the atomic mass is equal to the protons plus the neutrons. And if you need to go work backwards to find the neutrons, you subtract the mass minus the protons. If you get stuck, rewind this tape and listen to that again. That should help you fill in the rest of this table, and everything should be there. All right, so the term that's used for valence electrons, oh, I just gave it away. Valence electrons is the one in the last outer shell. And if we learned anything from the last part, I'm going to tell you right here, you can fill in the atomic mass, will be right there. And you can fill in it with the atomic number. So that should tell you the number of protons right away. You should be yelling that at your screen. Mr. P, this is too easy. Also tells you the electrons. So for this one here, you're going to make that model we did at the beginning. Only the electrons, though. So if you look, it has 16 protons, therefore 16 total electrons. So you need to make 16 of these blue dots. I'm going to hit copy. Move this one over here, save some space. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So remember, on the first ring, I'm going to type this out again. The first ring can hold up to 2 electrons only. Second and the third ring can hold a max of 8 each. What I'm going to do is place them. So first 2 go on the inside here. 1, 2. All right, once you fill up a shell, you move out 1. So I still have 14 left. I've only placed 2. So out of the 16, I've put 2. So then I do 8 more in this next one. Because remember, even though I have 14 left, I can only fit 8 in this ring. All right, so then what that does, that leaves me a total of 6 electrons that are left. And they go on the outside ring because they're the valence electrons. And if you're catching on here, if you look on the periodic table, sulfur is in the 16th group. So that'll tell you it has 6 valence electrons. So then I'm going to go ahead and hit save. And then you can see that the picture pops up. Easy for me to grade. Now, that's called the Bohr diagram. That's the same one that we worked on at the top on the first one. So if you have any questions on how to do this one, go back and rewatch what I just did, or go back to the beginning of this video and watch the first like 5 minutes or so. This electron dot diagram is exclusively the valence electrons only. Only the valence electrons here. So if you look at this one, I had 1, 2, 3, 4, 5, 6 electrons on the valence shell. I only had 6. So that means I'm going to put 6 on this one. Now here's something I want you to see. I'm going to go ahead and you don't have to do this part. I just want to demonstrate it to you. So you're going to pretend that there's an invisible box around the S. And on each side of the box, there can be 2 electrons. So it'll be like 1 and 2. On each side of the box. So I have a total of 6. So I've made 1, 2, 3, 4, 5, 6. I'm going to place 1 on each side of the box and then double up. So if I have 1, now I have 2, 3, 4, and now I can go back and start to add more. 5, 6. What that should show you is that if you have a full side of the box, it needs 2 electrons on each side. So that leaves 2 obvious spaces, one right here and one right here, for electrons to go. So when we get into bonding, this will be a clear indication that sulfur wants to take 2 electrons. So like I said, you don't need this box. It was just a demonstration. So your atoms should look something like this. You can kind of adjust this so they're closer. And hit save. And go back and make sure this worked. All right, mine's giving me some problems, so just hang tight. All right. So then on this bottom, it's bringing it all together. All right, you're using the Bohr model and the periodic table and the electron dot. So up top here is this going to be your Bohr model. On the side here, this is going to be just basic information of the atoms based on the periodic table. And down here, this is going to be the electron dot. So you have basically 3 points on each one. So this is 1 point, this is 2, and this is 3. So first you should start here. And in these blue boxes, you're going to type the number of protons, neutrons, and electrons. So I'll do the first one with you. The first proton is the atomic number. This stuff should be easy for you now. Duh, Mr. P, I know this. All right, and that also tells you the electrons. The number of neutrons is the protons plus the neutrons is equal to the mass. So what number plus 3 is equal to 7? That should be 4. So now you come over here and you place this total number of electrons on your diagram. So whatever this number E is here, that's how many copies of the blue dot you need to make. So I have 3. So I'm going to make 3. So I have 1, 2, 3. Remember the rule, 2 go in the first one. So 1, 2. And then you can move out to the final shell to place the last one. So you should have 1, 2 on the first ring and 1 on the second ring. Now, this down here represents the valence electrons. So the valence electrons is however many are going to be on the last ring here, there, or here. So whichever one's on the outside ring, that's how many dots you put around this one. So since there's only one out here, I'm only going to put one there. That's it. I'm done with the first one. Right, on the second one, I'm gonna make one of these dots to come over here. So fill in this. All right, so you should get 10 protons, however many neutrons. You have to calculate that. I'm not going to give you all the answers, but I'll give you the first two because they're simple: 10, 10, and 10. So 10 here, and that means there's going to have 10 there. So you're going to need to make 10 copies of this. And remember, 2 electrons can only fit on the first ring. And then the rest of the electrons will go on the second ring. And remember, down here is only the valence electrons. So you go around once, 2, 3, 4. And there are 4 more. 1, 2, 3, 4, 5, 6, 7, 8. So then I would need to place 4 more around neon again. And for magnesium, it's the same steps, but you're going to have 3 rings. Remember, you can have 2 in the first ring, 8 in the second and the third ring. So once you fill up one ring, you have to go out to the next ring. I'm going to let you guys do magnesium on your own as a practice. Remember to hit save and close. And then it pops up like this for me to grade nice and easy. So that takes me to the end of what we're doing today and in this document. Remember to go to the Schoology assignment for this and hit submit. Please don't share this with me on Google Docs. If you have any questions, pause the video and go back to different parts that you need throughout the video, or reach out to me on Schoology or email so I can help you out. So hopefully this helps, and you can turn this in soon. Again, if you have any questions, please reach out.